Hey guys, and welcome to the school station. Today's video is going to be about current and voltage. This from the AQA GCSE Physics 91 paper from the unit Energy and Energy Resources. Today's video is going to be about current and voltage. Voltage is also known as potential difference. Today we're going to be talking about its formulas, its examples, and what they really are. So let's just get right into the video. So first of all, we have to think about what is charge. Now, you probably are asking, how does charge get into current and potential difference? Well, charge actually plays a huge role of finding out what is potential difference in current. And without knowing what is charge, you won't be able to understand fully what is current and potential difference. Therefore, I'm going to be teaching you guys what is charge first. Charge is a packet, quanta of electrons moving through a circuit. It is measured in coulombs. So first of all, you have to think about, it's basically like a packet of electrons. Now, we have to say that we have to really think about electrons. Now, if you have seen my chemistry videos, you will know that electron is a subatomic particle and it's really small. If we was to actually say that one electron, if we was to look at one electron moving through a circuit, like in a wire, when we're like, let's say we're turning our hairdryer, and one single little electron is going through from the electricity mains to our hairdryer to actually get out the wind, we could actually say that if we was looking at one single electron, it would be too small and very difficult to look at. Therefore, we actually have to say that charge is a packet of electrons, because since electrons are too small, they actually have to group together and then they have to move through a circuit. So therefore, charge is a packet of electrons moving through a circuit and is measured in coulombs. So what we have to really know is that charge is electrons moving through a circuit, and to symbolize charge in a formula we put Q, and the reason why we put Q is because Q stands for quanta, which is a packet of electrons. So quanta is represented by Q, which is what we symbolize charge by in formulas, and to symbolize coulombs, which is the units for charge, we put C. So this may seem a bit difficult for you to understand, but the reason why we symbolize, like, for example, when we symbolize, let's say, energy, we just put E. But for charge, instead of putting C, we put a Q, because charge is a quanta of electrons. So to symbolize charge, we put Q, and to symbolize coulombs, we put C. And these are what you're going to have to remember, because these can come up in your examples, and you're going to have to know how to represent them, and you can't just put C for charge, because the examiners are going to be looking at how you represent the units and also its definitions. So now we're actually going to be looking at what is current. So now that we've clarified what is charge, it may take a bit of time to process, but there is two types of current. There's electric current and just current by itself. So both of them are very similar. Electric current is a flow of electrical charge, namely negative electrons. So as I said, charge is basically when a packet of electrons are moving through a circuit, and electric current is basically looking at the flow of it, so how easily can it flow in a way. And current itself is the amount of charge that flows per second, coulombs per second. It is measured in amps, and coulombs per second is really important, because that's going to be our formula, which you're going to be looking at later on. But basically, current is the amount of charge that flows per second. We just want to current is basically like saying how many packets of electrons can we quickly go through the circuit per second, because obviously electricity and electrons go through very quickly. So we want to see how much of these packets of electrons can we go through the circuit per second, and this is measured in amps, because that's the units for it. Again, if you want to symbolize current in amps, there are actually ways of symbolizing it. To symbolize current, you don't put a C, you actually put an I. And also to symbolize amps, we have to put A, which is perfectly normal because amp starts with an A, so you just put A. But remember, to symbolize current, you have to put an I, not a Q or not a C or anything like that. So that's basically what you're going to have to remember for the exam. So current is the amount of charge that flows per second. How many packets of electrons or how many quanta of electrons can we allow the circuit to, how many packets of electrons can we let go in the circuit per second. So now that we've explained to you guys what is current, we can now look at what is potential difference / voltage. So potential difference is the amount of energy transferred per unit charge. It is measured in volts. So basically it is the amount of energy transfer. So this time we're looking more at energy. So the amount of energy transferred per unit charge, and it is measured in volts. To symbolize potential difference, we have to put a V, and if you don't want to remember it like that, you can just do potential difference is voltage. So to symbolize voltage, you put a V, and it's more easy to remember. And also to symbolize this unit, which is volts, we also put a V. So it is the exact same thing for the units and voltage itself. We can represent it using V and V. So that is what potential difference is. Not really anything much to think about. It's just the amount of energy transferred throughout the circuit. So now that we actually have found out what is potential difference, what is current, what is charge itself, we now can look at the formulas. So we're going to be looking at two formulas today. The first formula is the formula for current. So the formula for current is actually current is equals to coulombs per second, because remember when I told you guys that current is the coulombs per second, and I said that this is going to be relating to our formula. This is exactly what the formula is. Current is equals to coulombs divided by, or charge divided by, the time, and we can just remember this by coulombs per second. How many coulombs can go through in the circuit per second? So this is how you remember it. Current is equals to charge divided by time, and again, as I said, current is symbolized as an I, charge is symbolized as a Q, and obviously time is symbolized with a T. So current is equals to charge divided by time, and we also have to think about using this triangle. You can also remember this triangle, and let's say if we want to actually, if we have the current and we have the charge, we want to see how much time there is, we just cover up the time and then we can do charge divided by current. So that's basically how you would kind of use this triangle. So it's really important to remember this formula, and just to test on how much you can use this formula, I want you guys to go on and try this example. Calculate the current flowing when a charge of 240 coulombs flows through a device in 80 seconds. I want you guys to pause this video and try to do this question yourself before continuing with the rest of the video. Alright guys, I hope you guys have tried it out. If not, do not worry, because now we're going to be going through it. So obviously in this question we are given the charge and we're given the time. So obviously charge divided by time is current. So this is exactly what we have done. We have done charge divided by time. Current is equals to 240 coulombs divided by 80 seconds, and we got 3. And obviously the units for current is amps, so it's 3A, 3 amps. That's perfectly normal and perfect. So that's basically how you would solve the current for this example. And obviously you can go through more examples in your free time or after this video, but I have to quickly go through the potential difference formula, or the voltage formula, whatever you would kind of call it. But basically the formula for potential difference is energy divided by the charge. So how do you do this? You basically have V, which is symbolized a potential difference, and W is work done, but that's not really relating to this formula at the moment. But work done can also be represented over here in top of charge, top of energy, because if you guys don't know, work done is equals to energy transfer. So sometimes they can give it to you as the work done, but energy divided by charge, or work done divided by charge. So that's basically what the formula for potential difference is. Again, we can use this triangle over here. If let's say instead of if we're given the charge and we're given the energy, we can then solve voltage. But if we are given the voltage and we're given the if we're given the energy, we can do energy divided by voltage to find charge. So that's basically how you would use this triangle again. So that's the formula for potential difference. Really important to memorize and understand. But now we're going to be going through an example. Again, I really want you guys to try this before continuing with the rest of the video, because it really helps you to actually try to solve it by yourself. So this is asking us how much energy is transferred when the potential difference is 120 volts and the charge is 2 coulombs. This is a bit different, but if you use a triangle, you actually be able to find out the answer. So pause this video and try to do this question. Alright guys, so I hope you guys spotted that we are given the potential difference, 120 volts, and the charge, 2 coulombs, and they're asking us for how much energy is transferred. So they're not telling us to find the potential difference, which we were actually looking at. They're actually telling us to use this triangle to find the energy transferred. So how do you find the energy transferred? You do voltage times by charge. So what we're going to do is we're going to do voltage times charge. And if we do this, we do 120 times 2, which is 240 joules. And that's how much energy was transferred. And we obviously know that energy is always measured in joules. So energy is equals to 240 joules. And that would have been your answer. I really hope you guys have learned something out of this video, and I hope that you have enjoyed. Just as an overview of what we have learned today, we have learned quite a lot of things, and it's really important to try a lot of questions, remember to memorize the formulas, and really understand current, voltage, and charge. So we've learned the definitions of current, voltage, and charge. We've also learned the formula for current, which was coulombs per second, or charge divided by time. We also were able to solve questions involving current, and obviously you want to go and try more of these later on. We also have learned the formula of voltage, and we were able to solve questions involving voltage. I hope you guys have enjoyed this video. I hope you got something out of this. Give this video a thumbs up if it helped you, and subscribe to the school station for more free science and maths lessons. Bye guys!